Alright, last question. Let's try working through this series of enrichment questions. Now the question is, what is the square root of x squared? So it's nice to memorize this graph, or this expression. So in general, the square root of something squared is equal to the absolute value of that inside, absolute value of a. So in the same way, if you memorize that, the square root of x squared is going to be the absolute value of x. Now it's very easy to be tempted to say that the square root of x squared is equals to x squared to the 1/2, exponent bracket exponent, you multiply, which is simply x. But the truth is that you cannot actually have negative values, because when x is positive, a positive number squared out becomes positive, and you take the square root of a positive number, you have a positive result. However, if x itself is negative, that negative number is squared out, so the overall result is still positive. The square root of a positive number is positive, so we can't actually generate a negative number at all. So rather than just saying that the answer is x, in which x is a negative number, we have a problem. It's more correct to say that the answer is the square root of x. Let's try to visualize this on Desmos. Okay, we have a nice parabola here. That's the inside of the radical x squared. It curves upwards. Now what's the square root of this? The square root of 0 is here, and the square root of 1 is here, and the square root of 4 is here. You can see these numbers get crushed down, but it gets crushed down so it looks like a straight line. However, this is not a line that goes into the negative realm. The square root of this value here, the y value is 1, stays at 1. The square root of the y value here, which is 4, becomes 2. So when x is a negative number, the y value still remains above the x-axis. So if you call this f of x, and you type in y equals the square root of f of x, you can see that we have the absolute value graph, which is more correct than just saying y equals x. So let's type in y is equals to this sqrt of x squared, and indeed we have the v. So it's nice to know the formal definition of absolute value of x. There's two cases. The first case is just a line when x is greater or equals to 0. You know how to sketch y equals 1x, or just y equals x. It's just a straight line. However, we need to scratch off this part here, because when x is less than 0, we don't want this to be just a regular slope of 1. We want it to transform to be a negative slope, so we need to take the negative 1x. So this is a v, and it's good to memorize that the square root of x squared is simply absolute value of x. Let's take a look at this question here, square root of x to the 4. Now you could break this down to the square root of x squared multiplied by the square root of x squared, which would be the absolute value of x times the absolute value of x. So we have a positive version of x multiplied by the positive version of x, which is the same thing as just x squared, because regardless of whether x is positive or negative, when the number is squared out, it becomes positive. So the square root of x to the 4 is simply x squared. And here we're showing the result on Desmos. The square root of x to the 4 is the same thing as y equals x squared. Now what about the square root of x to the 5? This is the same thing as square root of x times x to the 4. So we previously worked this out here. The square root of x to the 4, we previously established that the answer is x squared. And we verify this on Desmos. The square root of x to the 5 indeed is the same as x squared root x. And notice how the graph only exists on the right half, because you can't take the square root of a negative x value. Okay, so now we're taking a look at x to the 6. Now, we could break this down to the square root of x to the 4 multiplied by the square root of x squared, which is the same thing. You multiply the insides of the radicals. It's equivalent. And we previously established that the square root of x to the 4 is simply x squared. And it's good to memorize that the square root of something squared is equal to the absolute value of x. So let's verify this result on Desmos. So we can see on Desmos the square root of x to the 6 looks like a very steep parabola. And when we type in y is equals to the absolute value of x multiplied by x squared, indeed it is the same graph. Now what happens if you make the mistake of writing x times x squared? Notice how negative answers are possible for the red graph. And x times x squared, by the way, is the same thing as x cubed. It's quite an innocent mistake to make, just thinking that you can just say the answer is x cubed, but it's actually technically incorrect. Because the truth is, the square root of x to the 6 must always be positive. You cannot possibly generate a negative y value. Finally, let's take a look at the square root of x to the 8. Now we could break this down to square root of x to the 4 multiply the square root of x to the 4, and we previously established that these independently become x squared. So we have x squared multiplied by x squared, which is x to the 4. So let's take a look. This one here is more intuitive. Let's see if it's true on Desmos. So indeed, the square root of x to the 8 is the same as x to the 4. Alright, it's your turn. Try these enrichment questions. Pause the video.